Okay, question 10. An object of mass 4 kg is attached to a spring with a force constant of 100 Newton per meter. So it is oscillating on a horizontal frictionless surface with an amplitude of 2 meter. And then a 6 kg object is dropped vertically on top of the 4 kg object as it passes through its equilibrium point. So the two objects then stick together, determine the change in amplitude as a result of the collision, and then the change in the period of the motion as well as the new total energy of the oscillating system. Okay, so in this case, we are gonna use a combination of chapter 3 and chapter 9 punya equation lah. Okay, firstly, we are gonna find the maximum velocity as it just passes through the equilibrium point. So that is just Vmax equal to omega A. Okay, so omega ni kita boleh guna formula square root of K over M. Okay, and then this is K over M times dengan dia punya amplitude. So this one is 10 meter per second. So this is the maximum velocity as it passes through the equilibrium point lah. This is before it is collided with the 6 kg punya object. Okay, so now we are applying the principle of conservation of momentum untuk inelastic collision, which is M1 U1 plus M2 U2 equal to M1 plus M2 equal to Vmax. Okay, yang ini untuk when dia, I'm just gonna put prime here lah sebab nanti bingung pula. Ini as it passes through the equilibrium point. This one as it passes through the equilibrium point ataupun at x equal to 0. Okay, tapi yang after ni pula, yang ini when the 6 kg object is dropped on top of the 4 kg punya object. Okay, so 4, this one is the one we've calculated just now, which is 10. Just gonna put U1 is the Vmax. Okay, plus dengan M2 which is 6 kg. Pemulaan dia belum ada lagi kan, dia belum kena apa macam mana? It is drop. So dia belum lagi move. So after tu baru dia ada movement. Yang time dia melekat sudah dengan the 4 kg punya object. So this is 4 plus 6. This is the maximum velocity that we have to look for, which is equal to 4 meter per second. Okay, so the new amplitude ni can be calculated using maximum velocity equal to total energy. Okay, so ini kita boleh guna half m v max square yang ini equal to half k a square. Okay, so half ni boleh cancel, which will give you the amplitude to be equal to 1.26 meter. Okay, so the change in amplitude akan equal to 1.26 2 minus 1.26, which is 0.74 meter lah. Okay, so that is the change in amplitude after ada 6 kg object tu. Okay, lepas tu kita perlu cari the new period juga, the change in apa ni? Okay, so the change in period juga. Okay, so firstly we have to find the old period lah. So the old period, I'm just gonna put T equal to 2 pi m over K. So m yang di sini kita akan guna for the 4 kg dulu lah. So 4 over 100, which is equal to 1.26 seconds. Okay, lepas tu untuk the new period, it is 2 pi m plus m prime k. So 2 pi 6 plus 4 plus 600. So dapatlah 1.99 seconds. Okay, so the change in period is 1.99 minus 1.26, which is equal to 0.73 seconds. Okay? And then lastly, we have to calculate the new total energy, which is E equal to maximum kinetic energy, which is equal to half mv max square, which is equal to half 10 for 80 joules. Okay? Boleh ya? So dari situ bila kita dapat this is the solution for question number 10 lah. Untuk this one, yang M ni, make sure you use both M ah, M plus M prime. Okay, sebab kita mau cari the new amplitude. Okay, I think that's it for question number 10.